So far we only looked at the two subband QMF filters, and only for the two band case in the Pseudo-QMF that we get perfect reconstruction. The PQMF, the Pseudo-QMF, extends the QMF approach to bands greater than 2. So for subbands, n is greater than 2 subbands. But it has only near perfect reconstruction, meaning that there is a reconstruction error in the filter bank. It is also a modulated filter bank like the MDCT, and it's using a baseband prototype filter H of n, that is a low pass filter. Its analysis filters are given by the impulse response given by this equation here, where L is the length of the impulse response. We see that it's an almost orthogonal filter bank, which means that the synthesis filter impulse responses are simply the time inverses of the analysis impulse responses. Its baseband prototype filters, they are now designed such that the aliasing cancels between adjacent neighborhood bands. So it's given these constraints that we design in order that aliasing cancels between adjacent neighboring bands, and beyond the adjacent bands the attenuation should go towards infinity. And this leads to near perfect reconstruction. So again, there is a reconstruction error. The PQMF filter bank used in the MPEG 1 and 2 layers 1, 2, and 3, it uses n equals to 32 subbands, and the filter length equals to 512. And this filter structure of filter banks is also used in MPEG 4 for the so-called spectral band replication, the SPR, and for parametric surround coding. There it has n equals to 32 or 64 subbands and filter lengths of 320 or 640. Here we see the PQMF used in MPEG 4 and the impulse response of the baseband prototype filter, the window, with n equals to 64 and L equals to 640, and here the frequency response of the baseband prototype filter.